In this video, we're going to be looking at orbital character and coefficients. So far, we've only been looking at homonuclear systems, where both the atomic orbitals have the same energy. But now we're going to look at what a heteronuclear system would look like. So here we've got a drawing of what a homonuclear MO diagram would look like. And we also have a diagram of a heteronuclear system. And as you can see, the atoms in the heteronuclear system are on different levels. So when drawing the MO diagrams for a heteronuclear system, we have to take this energy difference into account. So in a system where atom A has more energy than atom B, we can say that the bonding molecular orbital would look more like the low energy orbital because it's closer in energy, and the anti-bonding MO would look more like the higher energy orbital. And this is because the atomic orbital of B is contributing more to the bonding molecular orbital and vice versa. So knowing this, we can draw some diagrams out to visualize what this might look like. So as you can see, in the bonding molecular orbital, there's a sort of bulge around the nucleus of B, signifying that this MO has more B character and that the atomic orbital of B is contributing more to this molecular orbital. Similarly, when we look at the anti-bonding molecular orbital, we can see that there's a bulge around the nucleus of A, telling us that this MO has a more A character. Okay, so now let's put this into practice by drawing the MO diagram of LIH and how some of the molecular orbitals might look. So lithium's electronic configuration is 1s2, 2s1, and hydrogen's is just 1s1. And we have to remember that in order for our atomic orbitals to have sufficient overlap, they need to be at similar energies. So here we've got the orbital energies for lithium and for hydrogen. For lithium, its 1s is at minus 65 eV, and its 2s is at minus 5.4 eV. Hydrogen's 1s is at minus 13.6 eV. When we compare these values, we can see that lithium's 1s orbital is much lower in energy than any of the other orbitals, so we wouldn't expect this to contribute to the MO. However, comparing lithium's 2s orbital to hydrogen's 1s orbital, we can see that they're much closer in energy, and so we would expect there to be an interaction between these two. So if we've got a 2s from lithium with a 1s from hydrogen, obviously this is going to form a sigma bond. And we know that because we have two atomic orbitals interacting, we're going to form two molecular orbitals. So we also form our sigma star antibonding. So as we said earlier, we wouldn't expect our 1s electrons from lithium to interact. So this is down at the bottom, not bonding to anything. We can see that the lithium 2s atomic orbital is higher in energy than our 1s atomic orbital. And in the middle, we have the sigma and sigma star molecular orbitals. So let's put in the electrons to fill up the MO diagram. Okay, so now we've got our MO diagram drawn out, let's think about what the molecular orbitals might actually look like. Just like we said earlier, in a heteronuclear system, the bonding molecular orbital will look more like the atomic orbital that's lower in energy, and the anti-bonding molecular orbital will look more like the atomic orbital that is higher in energy. So as we can see, there's a bulge in electron density around the nucleus of the hydrogen in the bonding molecular orbital, and there's a bulge in electron density around the lithium nucleus in the anti-bonding molecular orbital.